today this is going to be number 19. So make sure we're labeling this number 19. Make sure you're on the front side. Yes? Yeah. All right, so number 19, and I can't see mine. There it is, number 19. All right, GCF and LCM. The definitions are important because we will see vocabulary on things like the test. All right, so LCM, what that stands for is least common multiple. All right, so now some of y'all, I hear some like, oh, I see some little heads going like, yeah, okay, I have heard of that. We might just not have called it LCM last year, which is fine. We might have said least common multiple. It's just shorter for our notes to write LCM. Okay? So a lot of times when we're writing it in class, we'll just put LCM real fast instead of having to write out least common multiple. Yes, Fernanda? Yes. All right, so least common multiple. Another word for least is smallest. So the least common multiple is the smallest multiple two or more numbers have in common. Okay, so it's the smallest multiple two or more numbers have in common. Alright, so the way we would make a list of multiples, that's like kind of what we were doing with our fractions. Remember we had the denominator to find the smallest one to use? We would take the two denominators and make a list of numbers. So like if I had 2, I'd start with 2, then I'd do 4, 6, 8, 10, 12, 14, 16. Alright, and then if I had 9, we'd do 9, 18, 27, 36, 45. All right. I'm going to show you an easier way to do that, or I think it's a little bit easier, because sometimes our numbers can get really, really big. All right. And if I'm making a list and I've got to go to a big number, that list is going to be really long. The longer my list, the more chances to make a mistake. So I'm going to show you another way to work that out, okay? All right. GCF, this is the greatest common, let's stop tapping our pens, please, factor. So instead of being the smallest, this is the largest factor what's left there? Do I need to move it over just a tad? The largest factor, 2 or more numbers have in common. All right, so an example of when we would use greatest common factor. So a factor is a number you can divide by. So I want you to think back to simplifying fractions. That number that I divided by, could it just go in the top? No, it had to go into both numbers, correct? What we were using there was a factor. If I use the greatest common factor, I only have to do that step once. Think back to simplifying. Sometimes when I simplified, I would have to divide like twice or 3 times. All right? What if this was a guaranteed way to where you only had to divide 1 time? Okay? So that's what the greatest common factor is going to be. It's the biggest number that will go inside of both. Okay? The biggest number that will go inside of both. All right? The first thing we're going to do, I'm going to give us a chance. Raise your hand if you need more time writing our definitions. A few of us, that's fine. Give us a chance to get those written down. So sometimes the number we can divide by would be larger than 12. All right, we could be dividing both of them by a number like 19. All right, those are going to be harder numbers to think of, aren't they? All right, so that's when this strategy is going to come in handy. All right, Chase? If it's an emergency, yes, it would be better because this is what we're fixing to do. We only have 2 examples we're going to do from each thing. So if we could wait until we finish the notes, that would be better. Okay? All right. On this first example, it says find the GCF. So here's where we're doing GCF. I'm just going to put a little box around there so when I look back at my notes, oh, there's the GCF problems. It's easy to find. Okay? Find the GCF of each set of numbers. The way that we're going to do this, guys, we're going to make something called factor trees. So the first thing I want us to do, guys, is I want to draw a line separating 12 and 66. So I have one side that's going to talk about 12, one side that's going to talk about 66. We okay with that so far? Yes.
You have to skip 2 lines behind the line, like you did?
Yeah, you're going to want at least 2. I might end up needing 3. It depends on how long my work is, okay? But I definitely am going to want at least 2. All right. So the first question I'm going to ask myself, what are 2 numbers that will multiply to give me 12? What are 2 numbers that will multiply and give me 12? Sarah? 6 and 6 times 2. 6 times 2. So what I'm going to do, guys, I'm going to draw a little TP. I don't know what else to call it. So it's a little arrow thing. All right, and underneath that, I'm going to write 2 and 6 because 2 times 6 gives me 12. Do y'all agree? Okay, do y'all see I've already split 12 up, so I'm going to put a little X through it because I've split it up. So 12 is really when I wrote 2 times 6, right? So do I need the 12 anymore? No. All right. Can 2 split up anymore?
No. Yes. Yeah.
2. All right, so think about it. So you're telling me 2 could split into 1 times 2. Isn't the 2 already there?
Yeah.
Yeah, so does multiplying by 1, does that give me any new numbers? No. So we're going to avoid 1s here. All right, so that's a really good thing to mention. We don't want a 1 because it's not really doing anything. All right, so I'm going to stop here at the 2. But what about 6? Can 6 split up? Fernando?
Yes, and 3.
3 times what?
2.
2. So I'm going to write 2 times 3. And you can write 3 times 2. It doesn't matter the order. I like to do small and then big just because then it makes my work easier to follow. All right, my 6, y'all see where I split it?
Yes.
So I'm going to mark it out. All right, because can I use it anymore? No. All right, 3, can 3 split up? No, not without using a 1. Those are called prime numbers. So 2 and 3 are prime numbers, which means we can't go any further. Are there any questions on how I split 12 up? Okay. Prime is not 1 is not considered a prime number. The smallest prime number is 2. I'm sorry? Nope. 10 is composite. 1 is neither prime or composite. Okay? It's neither one of them. It's not considered either one. All right. Guys, we're going to do the same thing with 66. I'm going to split it up. So the only thing I'm asking is, what can multiply to give me 66? And I'm going to use the first 2 numbers that come to my head. Morelli? 11 times 6. So I have 11 times 6, or you could write 6 times 11. All right, now that I split up 66, do I need it? No. Okay, so I'm just going to put an X there so I don't try to use it again. All right, can I split up 11? No, 11 is prime. There's nothing else you can multiply to get 11. All right, can I split up 6, Malin?
Yes.
What's 3 times 2? All right, or you can do 2 times 3. All right, so now that I split it, I'm going to mark it out. All right, can I split that number anymore? All right, so now comes the math part. All right, I say math part because we just did a lot of math, didn't we? All right, so what we're looking for right now, I'm going to put a little equal sign up here. I want to look for, if I look on the 12 side and the 66 side, what do those 2 sides have in common? Morelli? Okay, let me rephrase my question. What number is on the 12 side and what number was left on the 66 side? Davis, just one. 2. So does everyone see how I have a 2? And I can use this 2. How I have a 2 on this side, and y'all see my 2 on the other side?
Yes.
Which means that's got to be a part of my answer. So I'm going to put a 2 up here. Why did I circle those 2s? Because they match. It happens on both sides. All right, now that I have those 2, I'm going to mark it out. I'm done with those. Okay? Is there anything else that happens on both sides that matches? Brady? 3. So I have a 3 right here. And I have a 3 right here. Do y'all see where my 3's match?
Yes.
All right, which means next to 2, I'm going to write times 3, because that 3 is also a part of my answer. All right, and I'm going to mark those out because I already wrote them down now. All right, is there anything else that matches? Fernando?
6.
All right, look, my 6 is X'd out. So the 6 is X'd out. We can't use it. The only thing that's not X'd out now, I have a 2 and I have an 11. Do y'all see how X'ing that out helps me? Because the only thing that doesn't have an X is a 2 and 11. Do those match? No. So is there anything else that matches here? No. So here's my answer. 2 times 3 is 6. That's what I'm looking for. All right. So what that means, guys, is 6 is the biggest number that'll go into 12. Because can 6 go into 12?
Yes.
Yeah. And 6 is the biggest number that will go into, not the big, I'm sorry, let me rephrase that. 6 is the biggest number that will go into 12 and also into 66. Okay? Because can 6 go into 66?
Yes.
Yeah. So 6 is the biggest number that will go into both of them. Okay? Yeah.
The numbers that are not X'd out, those are the numbers that can go into 6. Like 11 can go into 6 and give us the answer, and 2 can give us.
No, 11 and 2 don't give us the answer. The answers come from the 2 that matched and the 3 that matched. Okay? Because look, we did 2 times 3. Our answer is just the 6, okay? So I don't want you to be thinking that we're doing anything with that 11 and 2. Okay? You're trying to add more work. We don't need the 11 and 2. All right, let's look at the next one. All right, and you'll see this time I did it past 3 lines. It really doesn't matter. These are just bigger numbers, so I'm thinking I might have to go further down in my work. That's really what I'm thinking. Brady, question? Addison, question? Y'all are both wanting to answer. I love it. Awesome. Y'all are like on top of it. Good. All right. So let's look at 32. What are 2 numbers that multiply to give me 32, Addison?
4 and 8.
4 times 8. Those are the first ones that pop into my head. So let's work through this side. So I have 4 times 8. Are there any questions on where I got 4 times 8? That's one of those multiplication facts we need to know, right? Okay, so now that I've done that, I'm going to mark out the 32 just so I don't accidentally try to use it. Okay, so now I have the 4. Can 4 split up?
Yes.
Davis?
Split up 2.
To 2 times?
2.
2. So I split up 4, so I'm going to X it so I don't try to use it. So 4 became 2 times 2. Are we okay with that?
Yes.
All right. Can my 2 split anymore? No. So let's go back over here to the 8. 8. Can 8 split up? McKenna? 2 times 4. So I have 2 times 4. And you can see I'm going to have to start writing a little small, so that's okay. All right. So I split up 8. I'm going to mark it out. All right. Again, why am I marking it out? We don't use it any other time because we're done with it. All right, can 2 split up? No. Can 4 split up?
Yes.
All right, what's 4 going to split into, Malin? 2 times 2. So now I split my 4, so that's done. So I should have 1, 2, 3, 4, 5 2s down at the bottom. Make sure you have all of those 2s. All right, we've got to make sure we have all of them. All right? Okay, so Brady, you had wanted to do 48. What numbers will multiply to give me 48?
24 times 6.
We can do 2 times 24. Malin?
6 times 8.
We can do 6 times 8. The one that's in our multiplication fact chart is 6 and 8, so that's probably the one most of us think of. But Brady, you can use 2 and 24. I want you to try it on your paper. You already did it? Okay, let's see if we get the same numbers, all right? I'm going to ask you at the end if we get the same stuff. Okay?
What about 12?
You can do 12 times
4.
4. You can do 12 times 4. All right, you can do 12 times 4, and let's see if we get the same stuff. So, Malin, we said we're going to do 6 times 8, right? All right, if you did one or the other one, in the end, we should have the same amount of numbers. They might be in a different order, and that's okay. All right, so I'm done with my 48. I'm going to put a little X on it. All right, can 6 split up, Shelby? What is 6 going to split into? 2 times 3, very good. All right, Harper, can 2 split? No.
8 can.
Okay, 8 can. All right, so Harper said those aren't going to, but 8 can. Harper Joe, I'm sorry, what's 8 going to split into?
4 times 2.
4 times 2. Okay, so my 8 is split. All right, is there anything else on this that can split up? Sean, do you see any other numbers here that I can split up? The 4, what's that going to split into? 2 times 2, so I'm going to mark out my 4. All right, so if you did it a different way, Brady, I want you to count up. How many 2s do you have down at the bottom of yours? Just on the 48 side. I have 4 as well. Good job. Do you have a 3 down at the bottom?
Yes.
Just 1? Perfect. Fernando, did you check yours?
Yes, ma'am.
Do we have 4 2s?
Yeah, I do.
And do we have 1 3?
1 3?
Mm-hmm.
Oh, yeah, I have 1 3.
Okay, perfect. So even though we did different numbers, Fernando even did a different number from Brady, we all got the same amount of numbers at the bottom. All right, so now what am I looking for now? So now I've got to actually start finding my answer. What am I looking for, Malin? We're looking for stuff that matches. So if I look on both sides, name one number that's going to match on both sides. Jose? 2. I have a 2 right here, and I have a 2 right here. And I'm starting at the front with those 2s because it looks like we might have a lot of 2s here. All right, so I'm going to put my equal sign, and I'm going to write my 2, and then I'm going to mark it out. I know it seems a little repetitive to circle it, write it, and mark it out, but that way I don't forget anything. Okay, what else matches? What else matches? Diego? 2. So here's another 2, and here's another 2. What my circle allows me to do is make sure that, hey, they're on different sides, right? 2 and 2. Okay, so that's another one. So I'm going to put times 2, and then I'm going to mark it out. Okay, what else matches, Fernanda?
2 2.
I have another 2. So here's another 2. Here's another 2. So I'm going to put times 2 again and mark those 2's out. All right. What else matches, Aaron? So here's another 2. And here's another 2. So I'm going to put times 2. And I'm going to mark them out. What else matches? Brady? Nothing. On this side, since I've been marking things out and setting my work up, I only have a 2 left, right?
Yes.
And over here, all I have left is a 3. Do those match?
Nope.
No, so let's multiply these. 2 times 2 is?
4.
4. Times 2 is?
8.
8. Times 2 is?
16.
16. Awesome job, guys. So that is my GCF. So what that means is 16 can go into 32. That's going to happen twice. And 16 can go into 48. That's going to happen 3 times. If I was just looking at this, I would probably only think of 8. Is 16 a number I'd be able to just think of in my head? Probably not. So that's why this method is awesome, because it does it for us. All right? Okay, LCM. Let's do an LCM. Chase, when we get done with the first one, if you really need to go, you can go, okay? All right. All right. Carlos, you okay? You with me? Yeah, you look are you just bored? Tired? Okay. It's math class. All right. Let's look at number 1 here, okay? I'm going to draw my little divider. So all that divider is there to do is separate my 2 and my 6. All right. Jaden, can 2 split? Can I split up my 2? No. Okay, and this is just like, and I'm sorry, I should have said this first, Jaden, before calling on you. This is exactly like what we just did. Exactly like up on the top. I know we're doing LCM. But we're going to start them the same way. Isn't that nice? It's nice when math works out kind of easy. Yes? All right, so 2, we can't split that up, right? All right, what about 6, Christian? What can 6 split into? 3 times? Times 2. All right, so I get 3 times 2, and I'm done with the 6, so I'm going to put a little X on it. All right, why didn't I write anything under the 2? Because it's done, right? Yeah, it's done. It can't split up. All right. This time we're doing our LCM. Have I done anything different yet? Nope. And I'm still going to ask myself first, what matches? So on number 1, what's going to match here? Brady? The 2. Do y'all agree? I got a 2 here and a 2 here?
Yes.
So that's what matches. So I'm still going to write equals 2. All right, so my 2's match. I'm done with those. I'm going to mark those out. Okay. All right, here's the difference, okay? We can't work them the same. The difference is if I'm doing, and listen to my letters in these words. If I'm doing the least common multiple, we also need what is left. So if I'm doing the least, my LCM, I need what is left. What was left over on this, Malin?
3.
The 3. So I'm also going to do times 3. Do y'all see the difference? So if I'm doing the L for least common multiple, we also do what is left over. So I put times 3, and what is my answer here going to be? 6. 2 times 3 is 6. All right, so what we're checking here, can 2, this time we're not asking if 6 can divide. We're asking, can 2 be multiplied to equal 6?
Yes.
Yeah, 2 times 3. Can 6 be multiplied to equal 6?
Yes.
6 times 1. All right, so that's where that M for multiple comes in. We're looking at, will it multiply to equal that? All right, let's look at number 2. We got 3 numbers here. Okay. Okay, so I'm drawing 2 lines to separate those 3 numbers this time instead of just 1 line. All right, Chase, 4. What, can I split that up? 2 and 2, very good. So 2 times 2, and I'm going to just put a little X through that 4. All right. Carlos, can I split 5 up? Nope. 5's prime. 5. It can only be 5 times 1. And do we want 1s? No 1s. Okay. So 5's done. All right. What about 10? 10. Tyler, what can 10 be split up into?
5 and 5.
Not 5 and 5. Close. 5 times 2. 5 and 2. Good. All right. Can I split? Okay, so I'm going to mark my 10. Can I split anything else up in here?
No.
All right. Now remember, the first thing we're looking for are matches. Raise your hand if you can give me a number that matches. Davis. 5. So I have a 5 in that last column. Where's my other 5? No, it's just right in the center, that big 5 in the center. Do y'all see how I have a 5 in the center and a 5 at the end?
Yes.
So I have a 5, so I'm going to put 5. I'm going to mark those out because I'm done. Now, basically, all that's happening is if it matches, I only see it once, right? Okay, what else? What else can match here? Any other matches? Aaron? 2. Are you talking about these 2's? Which 2's? So one of these and the one at the end. So I have one of these 2's and the one at the end. Aaron, why couldn't I use those 2's that are already together? Why couldn't I use those 2, Morelli? They're in the same column. They're already together. That's the problem. I kind of gave it away when I asked the question. All right. Since they're already together, that's not a match, okay? So I have 1 on the first column, 1 in the last column. So I'm going to put times 2 and mark those out. All right. This is the least common multiple, so it's got my L. So what is left? What is left over here, Carlos? The 2. We have a 2 right here, so I'm going to add a times 2 right there. Okay? All right. The 4, look, do you see how I have an X through it? Because I split it up. When I split it up, I put an X so I don't try to use it. Okay, so now it says 5 times 2, which is? 10. And then 10 times 2 is? 20.
I did it by myself.
Yes.
So, in this, 2 can't go into 4 and 5.
All right, remember, you're not dividing. We're asking, this is the least common multiple. Can 4 multiply to give me 20?
Yes, okay.
Can 5 multiply to give me 20?
Yes.
And can 10 multiply to give me 20?
Yes.
Okay.
That's what we're looking for. All right, good question.
Okay.
All right, let's look at number 3. Number 3. All right, can 3 split?
No.
No. Can 5 split?
No.
Can 7 split?
No.
No.
Just 357. 3 times 5 times 7.
All right, so what that means, guys, are there any matches here? No. So, good thing this isn't greatest common factor. Since this is least common multiple, I'm just going to use whatever was left. Well, what was left on this problem? 3, 5, and 7, because I didn't do anything to them, right? So all that was left was to use 3, 5, and 7. All right, Addison?
I was wondering why do I put 1?
Because they matched. So since they're already there together, I only use it once. Okay, good question. Christian? Yeah. Close. Let's multiply. So 3 times 5 is 15. I think you might be right. Sorry. All right, so we get 15. Sorry, Aaron told me the answer, and then I wasn't. Okay, let me move it over. So 3 times 5, I'm going to come over here to the side, is 15, and then I've still got to multiply it by 7, right? So 7 times 5 is 35. Carry my 3. 7 times 1 is 7 plus 3, 10. So I get 105. All right. So, guys, your homework is the back part. Now, I know that looks like we got a lot, but remember, what did I say I was sending out tonight, Christian? A video. And the video is going to go over more than half of these. All right? But I want you to get started in here so you can use that video to check your work. All right? So flip it over to the back, and we're getting started on